However, if we turn flat shading off, it's smooth. Hallelujah. Hello, and welcome to part 2 of how to code a game like 7 Days to Die in Unity. This is supposed to be the next Minecraft video. I know, I'm sorry. Things have gone wrong with that video, and be honest, the lesson I'm learning right now is to not promise that the next video will be a particular video until I have done that video. So I'm falling back on the notion that putting up a different video is better than putting up no video. So I will still be getting that video up soon. It just isn't as soon as I'd hoped. To this video. So in this one, we're going to cover smooth terrain, or what I think is also called dual contouring. And that is basically making all these sort of isometric-y looking shapes more terrain-like. So let's open up our script, and actually the first thing I'm going to do is if we just pull up our camera, I just want to change the background to solid color, and well, actually blue's fine, just to give it something that stands out a bit more from the color of the terrain at the minute, because the terrain and the sky were the same color. So first off, it wouldn't be one of my videos if there weren't a couple of little fixes to do from the previous video. So if we just go down to populate terrain here, and all of this is unnecessary. Basically. So all we want is we want to subtract the height, the current height that we get from our current position. That's all we need to do. We didn't need to do all the other stuff. I was getting a bit overzealous with my code. So if we run that now, it should still work fine. Yeah. So, sorry about that. Now, the next one isn't so much a fix as it is well, no, it's not an optimization. It's just make things a little bit easier for something that we're going to do. And that is this code here. So if you remember from last video, these represent the positions on the cube. So you've got your 8 corners. And then the overall, like the 2 part of the array here. So you got 1 vector 3, 2 vector 3. They represent an edge. So the start of the edge and the end of an edge. And then you've got your 12 edges. But these 8 corners are the same corners that we're using here. So it seems a bit pointless having all these vector 3s when we already have all the vector 3s we need stored here, and we can just point to those vector 3s. And that's exactly what we're going to do. And I've already worked all this out, so again, feel free to copy and paste it from the code in the GitHub. But we're just going to replace this table with this one. And each one of these represents an index that points to one of these vector 3s. So it's exactly the same table, all the same order and everything. It's just instead of storing these vector 3s in here, we're using these ones here and just pointing to them. And that's what these indexes do. So now we should have an error if we go up here, and we're going to fix that. So now we want to say if position plus corner table edge indexes, and then just the same again. And then once again, if I jump back to here and test that, that should work fine. Yep, we've not broken anything yet. Sweet. So the next thing we're going to do is create a little function. Again, this is all sort of building the groundwork for what we're about to do. So this is just going to be called void sample terrain, and it's going to take in a vector 3 int, which we'll call point. And all it's going to do is return a float from our terrain height map. I don't need to declare that. Terrain map point.x, point.y, point.z. And that just makes things, oh sorry, that should be a float. And that just makes things a little bit easier to type out, so we don't have to type out this every time when we need it. So the next thing we're going to do is we're going to move, we've got this code here, we're going to move that into our actual marching cubes array. We don't need to be creating this cube float array out here, we can do that in there, and it just cleans up the code out here. So let's get rid of that, take away that reference, and then if we go down to here, take away that. So it just takes in a position now. And then exactly the same as we did up there, cube equals float, new float, 8 in size, and then we want to loop through each of these, int I equals 0, I is less than 8, I plus plus. And then for each point of these, we're going to sample terrain, and we're going to pass in position. And this is why the order of this is relevant, and why switching to this makes our life a little bit easier, because we're populating the cube at the same order as these vertices here. So it's this corner, this corner, this corner, this corner, etc. And because we're using that same order, we can now sample the terrain at position plus corner table I, and that should be equal, sorry. We also need to make this a vector3 int, and then that should give us an error up here, which we can easily solve by making that a vector3 int. So the reason we're changing these to vector3 ints is because you can go from a vector3 int to a vector3 if we need to without any conversion, which is the direction that we typically are going to be moving in, but you can't go the other way. So I can't take a vector3, directly grab the x, y, and z and use it to reference this array, which is where the trick, for anyone who's watched the Minecraft tutorials early on, that's why we've got lots of mathf.floor2int converting floats to integers so that we can use them as indexes to access these arrays. This makes it so that we don't have to do that because we're already in ints to start with, and if we need to use one of these to set, say, a transform position or something, we can just pass in that vector3 int directly. We don't have to convert it or anything. So now we've got our cube, same as before, and that gets the index, and we're passing in a cube value which we've set up here anyway, so we don't need to change anything down there for that. And once again, if I press play, it should still work, and it does. Huzzah! Now the stuff that we're actually in this video for, the smooth terrain. So let's start off by creating a public bool which we're going to call smooth terrain. And this is just so we can turn on and off smooth terrain. It's not necessary for the 7 days to die part of it, because obviously 7 days to die doesn't have a non-smooth terrain option. But this is just while we're building things up, while we're getting our head around how everything works. It's just handy to have the ability to turn it on and off. And now for the tricky part. So if we go back down to our marching cube, and somewhere down here. So this is the part we need to change, or add to, is probably a better way of putting it. So we use that new bool that we've just created and say if smooth terrain, do some stuff, else do this stuff. So the way that we've already been drawing the terrain, that is the way that we're going to draw it if smooth terrain is turned off. And then we just want to declare this outside of the if statement, because you can't use a variable that has been declared. Well, you can't declare a variable inside a conditional statement, and that's still going to give an error for now because we haven't declared it in here. So there is theoretically a condition in which this is used but hasn't been declared, or hasn't been, what's the word, unassigned. That's it, hasn't been assigned. So in here, to start with, we want to get two floats, and we're going to call one vert1 sample, and we're simply going to get cube edge indexes indis o. And again, that is possible because we're using all of these to reference these rather than having this be its own thing. And I've typed something wrong here. What have I typed wrong here? Keep forgetting to put my equal signs in. That's what I've typed wrong. And if we just copy that, and this time we're going to call it vert2 sample, and this time we want the second of those. So I'll try and comment this as I go. And then after that, we want to calculate, spelt properly and typed properly. Maybe typing comments in the video isn't the best idea given how bad I am at typing. Calculate the difference between the two terrain values. And then to do the way we do that is we say float difference equals vert2 sample minus vert1 sample. Next, if the difference is 0, then the terrain passes through the middle. And then we enact that by saying if difference is equal to 0, difference equals terrain surface, else difference equals terrain surface minus vert, I'm pretty sure it's 1 sample divided by difference. And then finally, for all that, we calculate point along the edge that the terrain passes through. Vert1 plus 2 brackets there, vert2 minus vert1 times difference. I'm missing a bracket. Where am I missing a bracket? Right there at the end. There we go. So that I think that's everything. We press play. Well, actually, if we first check. Right, so smooth terrain's turned off. So that should just look the same way it looked before. Yep. And if I turn that on now, Hey, there we have smooth terrain. Well, smooth in geometry, not necessarily in appearance, and that is because we have flat shading effect, I guess you would call it. Now, I've had this conversation with a few people in the Minecraft videos because they're asking why it was necessary to, when I'm drawing a cube, why it's necessary to have a separate set of vertices for each face of the cube. So you've got 4 on each face, even though the top, the left and the front face all share the top left hand front vertices. So they could theoretically all just use the same vertex, and then you wouldn't need to put 3 vertices in for the same point in space. However, that creates a kind of smoothing effect and it makes your cube look rounded. Rounded's not the right word, but smoothed over, which looks kind of weird and is definitely not the crisp, sharp-edged blocks that you want from Minecraft. However, for this, we kind of want to go the other way. We want that smooth edge because we're doing terrain and we want it to look kind of realistic. So this is nice and smooth and all, but it's not smooth. So we need to share these vertices. We need to make it so that each one of these quads and triangles is not drawing multiple vertices when it doesn't need to. So let's go back to our code. And the first thing we're going to do is add another bool so we can turn this feature on and off as well. Public bool flat shaded. And then if we go down somewhere below match cube, we're going to add another function. Where did I put sample terrain? Let's put it next to that. And this one is going to return an int, and we're going to call it vert for indis. And it's going to take in a vector3 vert. Now what this is going to do is, well, first I will comment it as we go so it's easy to understand. Loop through all the vertices currently in the vertices list. So we're going to say for int equals 0, for int I equals 0, I is less than vertices dot count, I plus plus, and then in here, if we find a vert that matches ours, that's ours being this one here, then simply return this index. So what we're doing is we're looping through them all, and if we find one that matches the one that we currently have it here, then that means that this this position in the world has already been added to the vertices array, so we don't want to add it again. That's what we're trying to avoid with all this. So if vertices I is equal to vert, then return I. Now, if we get to the end of our list and we haven't returned a number, we haven't found a vert that matches, that means that this vert has never been added to this vertices list before, in which case we want to add it and then return the index of that one, which will be vertices.count -1. I'll just comment that again. Now, if we go up to here, now it's this part that we want to be changing. We'll stick our if statement here. If flat shaded. So if flat shaded, just do exactly what we did before. Else, triangles.add vert for indis vert position. So that automatically adds, if it needs to, it adds that vert to the vertices array. If it doesn't need to, it doesn't. And either way, it returns an index that contains this vert, which is all that we need. So if we turn flat shading on and run it, it should look exactly the same as it did last time. However, if we turn flat shading off, it's smooth. Hallelujah. And I'll just quickly show you what I was talking about with the weird edges when you... So if I turn flat shading off but turn smooth terrain off, so we should have those crisp, clear edges, the isometric style view. But with the smooth shading, you get this weird effect. All those sharp edges kind of get smoothed over, and that's what would happen with a Minecraft block if you shared all the voxels, shared all the vertices, rather than having separate vertices for each face. So this would be a relatively short video if I stop there, so let's go a little bit further. Let's go here, we're going to add a mesh collider. Yep, it's already there. And go into our code, and we are going to create a mesh collider component. And then in here, get component, mesh collider. And you know what, also in here, just to save a bit of time, we're going to say transform.tag equals terrain. More on that in a second. And then if we go down to build mesh, I think it is. The build mesh? Yes, build mesh. At the bottom here, we'll say mesh collider dot shared mesh equals mesh. So we're just taking the same mesh that we assigned to look at and we're assigning it to the mesh collider. So I don't know if there's a way of visualizing this, but basically if I click on here and then I click on that, you can see we have this collider, which is kind of been visualized weird, but as you can see down there, it is the same shape. Despite I think this is rendering the outer bounds, but either way, it's not important for what we're doing. So our next step is, well, first off, we want to, if we just go up to our tags, we want to add that tag. Terrain, because that's why, because if you notice we're getting this error here, we're trying to call it terrain or tag it as terrain, but there is no terrain. So if we press play now, we should find it's tagged as terrain. Yep, there we go. So the next thing we're going to do is create an empty object inside of camera, and then we're going to drag it outside of camera and child camera to that empty object. That's just to make sure they're both in the exact same position. And we're going to call this flying camera, and we're going to make a new script which we're also going to call flying camera. We'll drag that on there and open it up. And then in our update, we're just going to do, this is quick and dirty. This is by no means meant to be any kind of proper code. This is just to get something to look at, basically. We're going to say transform.position equals vector3.move towards transform.position. So the move towards is like kind of like lerp. So we're going from a position to a position. In this case, from transform.position to transform.position plus cat. Oh, sorry, I haven't actually got a reference to that. So we'll take a reference to camera and we'll just call it cam, and we're going to make it public so we can drag it in. So transform.position plus cam.transform.forward. That's right, I think. Yeah, that's right. Cam.transform.forward, and then we're going to times that by input.get axis vertical, and then we're going to plus that to transform.right. So we want the cameras forward, but we want the transforms right. This is why we have childed the camera down here, because we don't want this to look up and down, because otherwise you look down and then you press left and you're flying off into the sky, because now your left is facing upwards. It's complicated. So transform.right times input.get axis horizontal, and close off those brackets, and the value, the incremental value, we're just going to say time.delta time times 10. It's probably close enough. So if we just check this, we should have a reference we can drag a camera into. And in theory, if I press play, we should be able to move around a little bit. There we go. Nice and easy. And then let's get a bit of mouse movement going as well. So cam.transform.rotate, new vector3, and we want to rotate on the x-axis. This is confusing because we're rotating on the x-axis, but we're using the mouse's y-axis to do so. And to make it even more complicated, we're inverting it by making it minus. So input.get axis mouse y, and then we want to rotate the overall transform with a new vector3 0, and this time we're rotating on the y-axis and we want the mouse's x-axis. Input.get axis mouse x not. So now we should be able to look around as well as fly around. See, I've done something wrong here. This is the exact thing I was talking about with the left and right changing based on which way you're looking. So let me just figure out what I've done wrong there. So what I'd done wrong there was this one wants to be transform. Rotating on the x-axis using mouse Y is left to right, so that's transform, and then this one wants to be the camera transform. So now we can try and fly around again, and this time the world doesn't tip up. And we can fly down into our terrain like this. So let's go a little bit further. I'm going to create a UI image. I'm going to set it in the center by setting, it's already anchored to the center and its pivot point is in the middle, so we just set the positions to 0 and that puts it in the middle of the screen. I set the size to, well, let's go 4x4 just to make it a bit more obvious, and we'll just turn the transparency down on the color just so it doesn't stand out too much. And then what we're going to do is if we go back into our code and we're going to say if input.get mouse button down, mouse button 0, that means if we left click ray equals cam.viewport viewpoint to ray. So this is creating a ray using the camera's viewport position. So we're going to give it a position on the screen, which in this case is going to be smack bang in the middle of the screen. And we do that by new vector3 0.5f 0.5f, and then we'll just give it 1f. I'm not entirely sure that the z makes a difference in this particular situation, but either way. So that's getting a position in the smack bang in the middle of the screen, which is where that point is, and it's creating a ray from that forwards. And then we want a raycast hit, which we'll just call hit, and then we say if physics.raycast, and then we'll pass in our ray, and we want it to pass out to hit. And we can say if hit.transform.tag is equal to terrain, then debug.log terrain clicked. And then just so we can see that it's working, we'll say else debug.log nothing clicked. So let's just try that. Let's highlight the console actually. So you can see terrain clicked, and if I get the mouse over the top there. Ah, right, okay, so the nothing clicked isn't going to work because the if statement is inside the physics raycast. So let's just say, let's move this else to here. So if I click up here now, nothing clicked, but if I click here, terrain clicked. But what are we going to do with this? Last thing, let's go into our marching script. I'm going to create a public this time. Public void, we'll call it place terrain. I'm going to take in a vector3 pos. I'm going to create a new vector3 int, which we'll just call v3 int. All of this is temporary just to show you stuff working. Equals new vector3 int. And then we're going to use mathf.ceil to int. So this rounds up to the next integer. Pos.x. We will just copy those and change the values. Pos.x, pos.y, pos.z. Actually, that one wants to be, I don't know why I put z first. And then we're going to say terrain map v3 int.x, v3 int.y, v3 int.z. And we're going to set that to 0. And we're going to spell terrain properly. And then finally, create mesh data. And then we'll go back to here. And we can get rid of that. We know that works. And we'll say hit.transform.getComponent marching dot place terrain, and we pass in hit.point for the location. So now if I press play, we can modify the terrain. And it's a bit clunky because there's zero optimization on the mesh drawing itself, but you get the idea. And then what we can also do is copy all of this. Well, first off, we'll go back to here and we will copy all of this. And we'll say remove terrain. And then the only difference is that this is 1 and this wants to be floor. So now we're rounding down And the difference between just rounding and floor and seal is that just rounding will round to the nearest. So if it's 0.6, it'll round up. If it's 0.4, it'll round down. Floor to int will always round down. Even if it's like 0.9, it will always round down. And seal, same again, but will always round up. So we do that, and then we will copy all of this. And this time we're going to pass in 1, so that's the other button. And this time we're going to say remove terrain, which I think is what I called it. Yeah. So now we should be able to both add and remove terrain. And that's it. So let's just maximize that. And so that's the end of this video. I think we'll probably try and get some texturing going in the next one. Optimizations will be further down the line, obviously, because as you can see, this is all kinds of slow. Yeah, this is early days. But you can see that basically the basic terrain generation is up and running. Although my camera system apparently is not. And there's the for people who play 7 Days to Die, there's the famous diamond-shaped holes that never match up with the cubes. But that's it for now. I hope you've enjoyed this video. I will try and get this Minecraft video sourced and uploaded as soon as I can. I'm going to stop promising it though, because every time I say it's definitely going to be up next, something goes wrong and it doesn't go up next. So just know that it's not forgotten. It will get made, but I would rather put a video up and it not be the video you all want than put up no videos because I can't get the one that you want up. So bear with me on that one. And yeah, this, by the way, this hole in the terrain here, that's because we've reached the top of the terrain. We only gave it a height of 10, I think, or 8 or something, and that's the top of it. So that's it for now. I hope you enjoyed watching it. As always, thank you to my amazing Patreons for supporting me in making these videos, and especially thanks again to Professor DJ, who has Patreoned up at the sugar daddy / mama level. I'm presuming daddy, but I don't want to assume gender. And again, it's amazing that you guys want to plump up that extra cash to help me with these. It's not necessary, but it is greatly appreciated. And I will see you next time. Bye-bye.